Welcome to lecture number 3 for ECE 211, Circuits 1, Resistors in Series and Parallel. So here's what we're doing in this circuit, in this lecture. Here I've got a circuit with 3 100 ohm resistors. So like this one right here is 100 ohms, or 99.6. These are in series. On the breadboard, this is shorted left to right, so this resistor goes to this node, shorted the second resistor. Put 2 in series, and all the current through the first resistor goes to the second, that's in series. 100 plus 100 is 200, give or take 5% tolerance. Put 3 in series, it becomes 300 ohms. So in series they add. When you put resistors in series. In parallel, I've got 2 resistors and I put them side by side. So this is one resistor. Put a second one right next to it. So these two have the same voltage. Other side has the same voltage. 100 in parallel with 100 is 50. If I do 3 of them, 100 in parallel with 100. Get the wires in there. And the wire would rather bend than go on the circuit board. I got it. 100 in parallel with 100 in parallel with 100 becomes 33 ohms. So this lecture we're going to look at how that works, how to calculate the resistance of resistors in series, in parallel, and combinations thereof. So the objective here is to simplify a resistor network. I can take that resistor and replace it with this equivalent resistance. I'll be doing that by adding resistors in series and parallel. Now, this doesn't always work, but for some circuits you can simplify it. Let's start out with resistors in series. Now what we found experimentally is they add. Well, you can show that. Around this circuit, by conservation of current, the current through R1 is also the current through R2, also the current through R3. When you have that, the resistors are in series. From conservation of voltage, Vn is V1 plus V2 plus V3. V1 is I times R. V2 is I times R. V3 is I times R. Factor out the I's, then the net resistance is just this. And what you get is resistors in series, add. For example, if I have 100 ohms, 200 ohms, 300 ohms, the total resistance is 600 ohms. Can also go the other way around. If the total resistance is 1,000 ohms, I know R1, R2, I can calculate what R3 must be. That's resistors in series. Now let's look at parallel. What we had experimentally was 100, and parallel with 100 is 50. But 3 in parallel, I get 33 ohms. The way that works is as follows. From conservation of current, IN is I1 plus I2 plus I3. I1 is VA over R1. I2 is VA over R2. I3 is VA over R3. VA is VN. So factoring out the VN, I get the current is 1 over R1 plus 1 over R2 plus 1 over R3. Solving for voltage in terms of current, the voltage is this mess times current, that's the net resistance. So that's how resistors add in parallel. It's the sum of the inverses inverted. That works out. 1 over 100 plus 1 over 100 inverted is 50. 1 over 100 plus 1 over 100 plus 1 over 100 inverted is 33.3. That's just what we saw experimentally. Let's try something else. Suppose I have 100, 200, and 300 ohms. Then I get 1 over 100 plus 1 over 200 plus 1 over 300 inverted is the total resistance. All that together gives you 54.54 ohms. Or the other way around is if the total resistance is 100 ohms, so looking in, I see 100 ohms, and I know that R1 or R2 is 200, R3 is 300, solve for R1. So 1 over 100 is 1 over R1 plus 1 over 200 plus 1 over 300. Solve for R1. R1 must be 600 ohms. resistors in parallel. Now, here's where it gets kind of tricky. Suppose I have a circuit like this. Find the resistance between A and B. Well, to do that, I need to figure out which one's in series, which one's in parallel. The 100 ohm isn't either. It's not in series. Series means all the current through 100 ohms goes through the next resistor, and it doesn't. It splits. Parallel means the voltage on one side is the voltage on the other side. Voltage on each side matches. That isn't either. The 200 and 500, however, are in series. So this together gives you 700 ohms. I can now see 400 is in parallel with 700. I can now put these in parallel. That's now in series with 100. So that's kind of the trick. Do series and parallel. Find the resistors that are in series, simplify. Find the resistors that are in parallel, simplify. Keep going until I wind up with a single resistance. So to do that, I would have 200 in series with 500. Let's do that in MATLAB. I'd have R1 is 200 plus 500. 500. Don't really need MATLAB for that. Call this guy R2. Put these two in parallel. R2 is 1 over the sum of the inverses. 1 over 400 plus 1 over R1. Total is 254 ohms. That's in series with 100. And one way to do that is redraw it. So this all gets replaced by 354 ohms. And it's pretty clear that those are in series. Total is 254. Total is 354 ohms. So this you can calculate in MATLAB. Just have in series they add, in parallel the sum of the inverses inverted. Series they add. I can solve that in MATLAB. This is where HP calculators really shine. Try to do this on your calculator. TIs sort of work, not really well. HPs work really, really well. Basically, Hewlett-Packard is a company of electrical computer engineers, and surprise, surprise, they build really good calculators for electrical computer engineers. The thing about the HP calculators, bring it up, they use a thing called reverse Polish notation. If you look at them, there is no equals button. They operate on the stack. Here's the stack right here. When I add, subtract, multiply, and divide, it operates on the stack. So to do two numbers like 2 plus 3, I first have to set it up. Do 2, enter, that's a push command, 3. Now the stack is set up, I can add 2 plus 3. When I multiply by 7, it automatically does a push. So there's 5, I hit 7, it pushes the 5 on the stack, and 7. Now the stack is set up, 5 times 7 is 35. Divide by 6, 35 over 6 is 5.833. That's how the HPs work. So let's go back to this problem. To solve this circuit, there. Let's do the 200 and 500 in series. Let's do 200, push that on the stack, 500. Stack is set up, 200 plus 500 is 700. In parallel with 400, in parallel you take the inverse, take 400, find the inverse, add inverse, this is 254 ohms. In series with 100, 354 ohms. Now I defy you to do this with a TI calculator. Like suppose this is a test. I've got to get to the answer quickly because I got another problem to work on. What I would do is 200, enter 500, plus, in parallel, inverse, 400, inverse, plus, inverse, 100, in series add, done. Try doing it that fast with a TI calculator. In Circuit Lab, you can check your answer. Like saying that you don't need Chegg. Chegg, I'm not sure what the cost is, like $50 a year. It's too expensive. You don't need it. You want to check your answer, just throw it in Circuit Lab. Build a circuit in Circuit Lab. Add a 10-volt source, or pick your favorite source. I like 10 volts. And then find the current flow. From V equals I times R, under the voltage, under the current, take the ratio, that's the resistance. From the voltage and current, that apparently is 354 ohms. That should be the same thing that I calculated, and it is. So give or take some rounding. Third way to measure it is what we'll be doing in some of the homework sets. Here's the circuit. I'll build it, apply a voltage source, measure the current. Now to measure the current, again, you could use an ammeter if you had an ammeter that didn't have a blown fuse. What you normally do is measure the voltage. Find this current. I'll find the current through this resistor right here. Measure the voltage across the 1 ohm. Measure the voltage across R1. From that I can find the current. If I know V1 and I1, I can find the impedance. And again, you could do this using Chegg. You could do it using ChatGPT. Problem with Chegg and ChatGPT is they sometimes get the wrong answer. It doesn't really help you learn what's going on. It's not necessary. If you want to check your answers, just go to Circuit Lab. In Circuit Lab, you can find out what the voltages are, currents are. Your calculations should match. If they don't, you did something wrong. Plus, Circuit Lab is a really nice tool. Use it in industry. Third way is build a circuit. You don't need Circuit Lab, or you don't need ChatGPT. You don't need Chegg. They're a waste of money. Okay, second example. Find the resistance of this circuit. Okay, let's do it a couple different ways. In calculations, these two are in parallel. So 200 in parallel with 300 is 120 ohms. So take all this and replace it with 120 ohms. I now have 120 in series with 500. It gives you 620 ohms. So take this, and all this gets replaced with 620 ohms. I now have 620 in parallel with 400. Gives you 243 ohms. So all this becomes 243. In series with 100 becomes 343. There's the answer. Okay, that's one way to do it. In MATLAB, I could do that. In MATLAB, what I would do, you can find MATLAB. Let's say R1 is 200 in parallel with 300. That's 1 over 200 plus 1 over 300. That's 120 ohms. R2 is R1 plus 500. That's in series with 500, 620 ohms. In parallel with 400, R3 is 1 over R2 plus 1 over 400, 243 ohms. In series with 100. Voila, there's your answer, 343.13 ohms. Third way to do it, let's use an HP calculator. Let's clear out the old command. I got 200 in parallel with 300. That's 200, inverse, 300, inverse, add, inverse, 120 ohms. In series with 500, 500 plus. In parallel with 400, inverse, 400, inverse, plus, inverse. In series with 100, 343 ohms. Fourth way, Circuit Lab. Here's the circuit. Let's add a 10-volt source to it and find the current flow. With Circuit Lab, I can actually find that current. Just click right here when the light turns on. That'll tell me the current, 29.14 milliamps, the voltage, 10 volts. The ratio is the resistance, 343 ohms. So here's a challenge for you. Find the resistance between A and B. Let's pause the video and have you find it. Okay, in MATLAB, find out series and parallel. So these two are in series. R1 is 200 plus 300, 500 ohms. That's in parallel with 400. R2 is 1 over 400 plus 1 over R1, 222 ohms. In series with 100, R3 is R2 plus 100, 322 ohms. In parallel with 500, R4 is 1 over 500 plus 1 over R3. One plus 1 over 500 plus 1 over R3, 195 ohms. So there's the answer. Let's try that with an HP calculator. With an HP, I would have 200, enter 300. Those are in series, they add. Parallel with 400, inverse, 400, inverse, add, inverse, 222 ohms. In series with 100, 322. In parallel with 500, 195.94 ohms. There's MATLAB. 195.9459. Same answer. Okay, so that's kind of series and parallel. Kind of one comment. Series and parallel doesn't always work. For example, in this circuit, I can't find the total resistance looking in because, well, these aren't in series or parallel. Nothing's really in series or parallel. There's nothing that simplifies. So there are circuits, there are topologies that you can't simplify. It still has resistance. If I build this physically, by a voltage source, it'll draw some current. Build this in Circuit Lab. Apply 10 volt source. I'll get some current flow. Voltage divided by current gives resistance. There is some impedance. The techniques that we know so far won't find it. We'll be able to find that using current loops, voltage nodes coming up later. So if there's a circuit you can't find an answer, that is possible. So kind of in summary, resistors in series add, resistors in parallel add as the sum of the inverses, inverted. You can check your answer using Circuit Lab. You can also check your answer by building it in lab and measuring it. And that is lecture number 3 for ECE 211, Circuits 1, resistors in series and parallel.